and welcome to today's talk. It's on providing secure ingress into a multi-tenanted cluster using Gateway API in a Kubernetes native manner. A bit wordy, I know, I apologize. In terms of what we shall talk about today, just in brief, start off with a quick introduction of who am I. We'll go into some terminology so that we're all speaking the same language. I'll briefly mention some services that are used to enable this automation and so-called Kubernetes manner. We'll speak briefly about the architecture of the solution or architecture of the demo that I'll be providing today. I'll then try to justify why Gateway API. The numbers are incorrect there. It should be 5 for why Gateway API and 6 for demo. And in summary should be 7 and question should be 8, but I can't count. So we'll fix that later. So briefly, who am I? My name is Thameez Bodhanya. I'm originally from South Africa, currently living in Berlin. I'm the engineering lead of DevOps and SRE at Forward Earth. Forward Earth, briefly, is a company based in Berlin. We offer carbon management software solutions, carbon calculations, if you're familiar with the space, CBAM, PCF, CCF, etc. If you need carbon data for your company, either for climate information or regulatory reasons, please reach out to us. My team is actually hiring right now, so if you're looking for a role in the SRE platform DevOps space, reach out. Note on this QR code, the second one here, it reaches our HR system, which isn't available on DNS that uses AdBlock. I tried to ask them to change that. Unfortunately, they can't. So if you can't reach that, just reach me out on LinkedIn and we can chat. Cool. So in terms of terminologies, that we're speaking the same language. Before I get to that, though, how many of you are familiar with Kubernetes? Okay. From that number, how many of you use Kubernetes? Okay, good. That's a good overlap. How many of you are familiar with the classic ingress object and use ingress? Okay, and how many of you are familiar with Gateway API and use Gateway API? Okay, so we're going to have some interesting Q&A, I assume, then. Okay, so that just gives me an idea of where to pitch the talk and where to go a bit deeper. So I'm not going to spend too much time on Kubernetes. But Kubernetes is an open source platform, container orchestration tool, quite famous, quite used. It's on 1.30 something at the moment. It's quite boring technology in my opinion. It's gotten to the state of completely stable. More important though is multi-tenanted. What does multi-tenanted mean in general and what does it mean in this context? Multi-tenanted refers to a system architecture where you have multiple users. They share the same resources, they share the same infrastructure, but they access their data. Their configuration should be logically isolated and distinct. Tenant A shouldn't be able to access tenant B's data. In the Kubernetes cluster, you have a single cluster with multiple actors, multiple tenants in that cluster. If you're offering a managed container service, these tenants could be different companies. If you're a platform team of a company, these tenants could be different developer teams, and they shouldn't be able to interact or impact other services that are running in the cluster that they are not owners of. Ingress in general refers as to external access into something. In Kubernetes terms, your cluster is generally closed. The networking paradigm is closed. To allow access from external, you need to allow it via an ingress object, or you can use a system with an external load balancer. And the subject, if I will, of today's talk is the Gateway API. Gateway API is a set of resources, probably about 2 years old now, 2.5 years old, maybe going on to 3. Which extends the classic ingress object. It extends it with more flexible routing, first-party support for newer or more modern protocols like GRPC, TLS, and UDP. Classic ingress only supports HTTP, HTTPS in general. It's one of the hallmarks, though, is it has a better separation of roles, and it has native support for use cases like service meshes, traffic splitting, etc. We will expand on that in a bit. In terms of services or concepts used today, you need an ingress controller for this solution. You need an ingress controller for Gateway API. I've gone with Kong Ingress controller. It served us well in the past, and it continues to serve us well. I do understand there is a bit of contention at the moment with the open source version of Kong. They're no longer publishing the OCI images. You have to build it yourself. But the good thing about Gateway API is it's very intercompatible. The idea is that the resources should be able to work with multiple controllers. So shifting from a Kong Ingress controller to another Ingress controller, pretty simple to do. Cert-manager is another service we'll be using today. It's used to auto-generate and renew valid TLS certificates. In our example, our certificate authority will be Let's Encrypt, but it ties into other certificate authorities. External-DNS is another service we'll be using today. It's call to fame, or what it does is automatically create and manage DNS records. In our case, we'll be using Route 53. Again, this ties into other things, including like your Google DNS stuff. RBAC, Kubernetes, especially in a multi-tenanted cluster, RBAC is very important. It's used to ensure that tenants only have access to resources within their own boundary. In this case, we're considering their boundary to be their namespace or namespaces. The last bit of service or software concepts that we'll be mentioning today, but you don't have to use it, is HNC, or Hierarchical Namespace Controller. It's used to enforce labeling on namespaces. You can use a multitude of software to achieve this. HNC has also been deprecated, but for the more advanced features that we may touch on today based on time, HNC is fundamental to our architecture. It allows for sub-namespaces, but we'll get to that. Cool. So an architectural diagram of how controllers work in Kubernetes, and particularly how these sort of services that I mentioned come together. If you're familiar with an Ingress controller, this would look very familiar, and you'll be asking, okay, but what does GatewayAPI has to do with this? So we start off with the resource here, the HTTP root resource. This is a type of GatewayAPI resource. If you're familiar with Ingress, this may be an Ingress resource. When you apply this resource to the Kubernetes cluster, you in essence making a request to the kube server, the kube API server, which accepts this resource, and it does things. Again, this is a simplified talk, so does things we can expand on later in the Q&A. One of the things that it does is when an event comes in through your Kubernetes API server, it triggers an event, or you can have controllers which listen for specific events. Your Ingress controller listens for these sort of events. It listens for any impact that happens to these sort of routes, these sort of resources. So when the root resource is created, it triggers your Kubernetes Ingress controller. In this case, it's our Kong Ingress controller. It checks if this root resource is valid according to some predefined conditions, which we'll discuss a bit later. If it is valid, it will then start to trigger a few things. It will trigger the creation of certificates from your external, your cert-manager. Your cert-manager will then go to your certificate authority, create the certificate, complete the challenge, etc., etc. It will get the certificate and store it in a secret that can be accessed by your gateway. The other thing that it would do in our scenario would be that it would request DNS records that will go to your external DNS controller. It creates the DNS records in your DNS provider, and that DNS resource generally points to external load balancer. It will then finally go and create the route in the actual gateway itself, which will route the traffic from your external load balancer to the service in question. That results in this network kind of diagram, your network flow. Your actor, your external service provider, your external service user requests the service using the host name. That will go to your DNS resolver. It gets the DNS record, which points to your load balancer. They then send the request to the load balancer, which then forwards that request to your gateway. The gateway then forwards that request to your service, and that service that request finally gets sent to your pod. The request is certified using your certificate. And in general, TLS termination will occur here. It can occur here, or it can occur here depending on your configuration. So just a simplified view of how controllers work, how that results in what is created, and then the network flow in the resultant creation. So if you're familiar with Ingress, that looks pretty familiar. Like, that looks pretty much the same. So far, we're using an Ingress controller. We're using some resources that define stuff. Why GatewayAPI? And specifically, why GatewayAPI in terms of multi-tenant? One of the hallmarks or one of the design factors in GatewayAPI that differentiates it from your standard Ingress resource is that it's designed to be configured by multiple personas. And personas here can mean many things, but in terms of this example, your personas are your cluster operators and your tenants, your cluster users. And that specifically refers to two types of resources, which we'll be talking about today, which is your gateway resource or your root resource, which is generally prefixed with the type that it is. Your gateway resource, think of it as the top definition in your current ingress resource. It defines how external traffic enters the cluster. So it defines from your load balancer to your cluster what is accepted, which host names are accepted, what type of traffic is accepted, what ports, protocols, and it also defines what routes can be attached to that specific gateway. That is generally under the ownership of your cluster operator, your platform team, your DevOps team, your SRE team, whatever, whoever is in your cluster admins. They will define, maybe even your security team. They define from the outside what traffic should be let in. Your root resources, on the other hand, determines and defines how the traffic, once it enters your cluster, what happens when it's in the cluster and where does it route to. It, in essence, maps requests based on your hostname or path internal to the cluster to the specific backend service. So think of it as the bottom part of your ingress definition in classic ingress definitions. Why is this splitting of the config? Why is this idea of multiple personas important? The slide is not in order, but we'll fix that as well. Before we speak about why these personas are important in terms of multi-tenant, we need to speak as to why the gateway resource can be defined by your cluster admin, but the root resources can be freely defined by your tenants. It's because the gateway, at the end of the day, has the ultimate acceptance criteria of which routes are accepted in the gateway. So your tenants can create routes. They may be incorrect routes, trying to access maybe a DNS hostname that doesn't belong to them. They could be trying to access a service that's not in their namespace. They could be trying to interact with a service that belongs to another tenant. They can create all of that. But why is it considered safe to allow them freedom over these resources is that the gateway is the ultimate determinator of what gets accepted and what gets routed from outside to the inside. So these accepted routes can be based on hostname, they can be on route type, and they can also be on namespaces with standard Kubernetes matches. These Kubernetes matches are things like labels, annotations, etc. So going back to why the split of authority, the split of resources are important, it means we can enforce RBAC. It means that at the gateway level, we can enforce RBAC that says that our tenants cannot touch the gateway resource. They cannot touch the access. They cannot touch what controls what gets into the cluster. They can only touch what happens within their namespace and what traffic gets routed to them. Unlike ingress resources, where it's a single resource that's defined, so you either give your cluster users the full power to define what comes from outside in and where it goes once it's in, or you don't give them any access, which means that ingress into your cluster is limited and blocked by your cluster admins, by your platform team, by your SRE team, which slows things down. And in general, why GatewayAPI, specifically for us and may be useful to you, is that it has less vendor lock-in. If you're familiar with ingress, due to the nature of how it's defined, you end up with a lot of annotations on your ingress objects that are very specific to your ingress controller. This means that it's less portable. It means that you're also very tied down to the vendor that you've chosen to be your ingress controller. As I said at the start, we chose Kong, but because GatewayAPI does not rely so heavily on these annotations, in fact, in most cases, you don't need any annotations. In the background, you can swap out your ingress controller for another ingress controller, and your existing GatewayAPI resources will just work. Another one that was big for us is that GatewayAPI also has first-party support for protocols like GRPC, TLS, and UDP. If you've ever had to configure GRPC routing in classic ingress, you know how much of fun that is. So there is some justification as to why GatewayAPI works specifically in a multi-tenanted cluster, RBAC, separation of resources, and some nice to haves like vendor lock-in and first-party support. Okay, we're going to go to the demo. This is going to be a live demo, so we're going to hope that it works, and if it doesn't work, we're going to try some backup stuff. So the first thing that I want to show you today is just, can you see that? Is that large enough? Yeah? All right, cool. Is our DNS provider, Route 53. I just want to show you that currently there aren't any DNS records. Well, there's the backups, but we're going to ignore those. There's none of these services that we're going to be displaying today. I want to show you the run from end to end. So from the time I apply a resource, in this case a HTTP route or GRPC route, to the time of application, to the accessing of that resource. So as proof, there's no current routes that are created. There's no DNS records for that. We're going to be looking at a few resources today. I set the talk specifically to allow for larger Q&A on specific resources. So I'm going to show a bunch of resources. I'm going to mention a few things about those resources. And if you have any questions about the resources in the Q&A, we can go back to them. So the first thing I want to show is the gateway resource. I'm just going to describe it, which is going to show us a lot of information, but I will scroll up to the parts and highlight the parts that are important to us. So this is a gateway resource. A gateway resource is just a YAML document like any other Kubernetes resource. The first thing I want to highlight is this. This annotation informs cert-manager who the cluster issuer should be for this gateway resource. If you have multiple cluster issuers in your cluster, you can specify that gateway A uses Let's Encrypt pre-prod, gateway B uses Let's Encrypt prod, gateway C uses ACM, whatever it may be. The second thing I want to highlight here is that your gateway can take in a class name. You can have multiple controllers with multiple gateways in the same cluster. How we utilize it is we have an Ingress controller. Again, this is a common pattern for Ingress controllers, but the same principles apply in the gateway paradigm. So we have a controller for internal resources, and we have a controller for external resources. Our internal resources are a bit more free because that's just within our VPC, within our safe zone. External resources, that is more protected. It needs a bit more approval. Security needs to approve the gateway changes to that. The next thing I want to highlight in the gateway resource are the listeners. This defines what the gateway is allowed to listen for, the types of traffic, and the allowed routes that are assigned to each of these listeners. So remember earlier I mentioned that the gateway is the ultimate authority on which routes are accepted. Those are defined in this section under allowed routes. So in this example, I'm using a namespace selector, specifically a label selector. That means this route, which matches this wildcard hostname. As I mentioned, for our internal services, we're a bit more free. We allow a wildcard. For our external services, we need a full hostname, a full qualified domain name for us to allow you into the gateway. So this hostname can only accept routes, or only routes that have this label on their namespace can create routes for this listener. This listener accepts HTTPS traffic. It listens on port 443, and this section is populated automatically by cert-manager, and that refers to the secret that contains the certificates that certificate manager creates for this specific hostname. We have another route on the same gateway. This one can only accept routes from namespaces that have the label bar, right? So it has that, and we have another one called dev. So that's kind of things to highlight on the gateway. I can show you the YAML definition later if you'd like. The next thing to show is the certificate that's created when this gateway is created. Again, I'm going to briefly go through this one. Okay, so this certificate is created automatically when the gateway is defined. If you add a new listener into that gateway, a new certificate will be created, or rather added to the DNS names of the valid certificate, and this is created automatically for you. So you already have a TLS certified route for your Ingress. The next thing to do is to actually apply some resources. I'm going to apply a few of them, and then we're going to look at the resources. These are GatewayAPI resources. These are two types of routes. I'm going to be demonstrating an HTTP route and a GRPC route. As I mentioned, GRPC is a first-party citizen in GatewayAPI. So just to illustrate how easy it is to deploy a GRPC service. So I'm just going to apply these quickly. Come on, internet. Cool. All right. Let's just look at them quickly. In terms of your HTTP route, this is a type of API gateway resource. It has some metadata like any other Kubernetes resource. You tell it which gateway it should use. Again, if you don't have multiple gateways in your cluster, this can be defaulted. But if you have multiple, you need to specify this root should be controlled by this gateway. We have a host name. I want to point out that this is deployed to the team foo namespace. And if we look at the team foo namespace later, we would see that it has the label ingress subdomain bar, which means that this root will be accepted because it's being deployed to a correct namespace. And that then maps to a service like normal. We then have the service, we then have the deployment. Your gRPC root looks very similar to that. It has a name, it has a namespace, you tell it which controller it goes to, you specify a host name. This is going to the platform namespace. If we look at the platform namespace later, we'd see that it has the label ingress subdomain platform, which means that this root will be accepted into that. We then will look at the bad ones. The bad ones is trying to access a subdomain that is not accessible to it, and so it will be rejected. And similarly, for the bad HTTP root, we'd see that we're trying to deploy to team foo. However, it's trying to use another tenant's subdomain, and this will be rejected as well. Cool. So let's go have a quick look at the resources. Maybe I'll just move that up. Let's look at HTTP roots. So we're now in the team foo namespace, as seen here. We see that there's some HTTP roots that are created. We've got a good HTTP root and a bad HTTP root. We're going to describe the good HTTP root. There we go. I need to put that in front first. Okay, so we're going to see that a few things here. So we see what we defined in the YAML, but if we go under status, we'll see that this root has been accepted. The references are resolving. That means the traffic is being routed to us, and it has been configured in the gateway. So resolved refs mean internally it's going to be routed, and configured in gateway means externally it's going to be routed. If we have a look in contrast to the bad HTTP root, okay, we'd see that we don't have a matching listener host name, and the resolved refs are true, but we don't have a matching name because this guy is not allowed to be accepted. He's trying to use platform, which is tenant 2, in team foo's tenant, so that doesn't work. So to show this live in action that it has in theory worked, we can access good.bar and it roots correctly. We see that we don't have any TLS issues and we're getting traffic into our cluster. Contrasting, if we try to access bad.bar, we would see that it's not routing. And we can also see that if we refresh this, we would see that good.bar has a DNS record, but bad.bar does not, because the gateway controller will not request the DNS record unless it's accepted in the gateway. As I said, it's the final authority on what gets accepted. Okay, quickly moving on to the good gRPC root. If we run gRPC curl against the good guy, we will get a response. Cool, it just responds with us, tell us hello. And if we try to access the, let's see that the namespace with the bad one fails, and therefore a request against it would also fail, as we see that the record was not created. So yeah, I think that's it in terms of the demo section, so that we can, there we go. So we can focus a bit more on it in the Q&A if needed. Click, okay, on my slide, there we go, it's back. Okay, just start it from there. Okay, so then in summary of what I hope to have shared today, Gateway API brings power and flexibility specifically over native ingress objects. It is a powerful alternative, specifically if it's tied into other tools like cert-manager, external-dns, and it has the nice side effect of being distinct, which means you can then, moving on to the second point, means that you can leverage RBAC to control multi-tenancy access to it. Using standard RBAC controllers, you can allow access to the gateway resource to your cluster admins and root resources to your tenants. And then you can use config management, HNC, or other services to have control over the labels and annotations that specifically restrict what routes can be created and therefore what routes are accepted into the gateway and therefore secure traffic into your cluster. Okay, cool. At this point, I'm going to open it up to questions. If there are any questions, please shout now. I think there is a mic going around. The mic is not linked up to the audio, so yeah.
Yeah, so my question is basically, if I understand correctly, the matching only happens by labels, right? So what stops a tenant to create a label, matching the other tenant, basically?
So that's where things like HNC come into play, config management, or other services that control namespace labeling. So if I was to attempt to, for example, actually have it here. If I wanted to, so say, for example, I wanted to edit my namespace label, the specific Ingress subdomain label. In this case, I want to label my namespace platform with someone else's label, right? I do that. It tells me it's accepted. Cool. But if I actually describe the namespace, what HNC does in the background is it checks if this label is a managed label. If this label is a managed label, it will actually refuse to access it and update it. Did I use platform? Yeah. HNC does this check, it restricts it, but there's other tools that does namespace restriction as well, namespace labeling restriction. Also, it's not just restricted to labels, it's restricted to any Kubernetes matches. So namespace has, I think, label matches and I think annotation matches as well, but other resource matches in the same way. And if you're utilizing a service that restricts updates to those things that you wish to secure, your tenants cannot edit it. Additionally, you could use RBAC to also stop them from editing their namespace at all. Yeah, that obviously has its own restrictions, but that's also where HNC comes into play. HNC allows a client to have sub namespaces within their namespace. Cool. Any other questions? All right. Cool. Then I thank you for your time. And yeah, if you wish to discuss, reach out more, have any other questions at any point in time, you can reach out to me on LinkedIn. Unfortunately, I don't have any other social media. I thank you for your time. I thank you for spending the last session with me, and enjoy the rest of your day and the party. Thanks.